All right, welcome to another episode of Talking Metaverse. I'm Tan, and today I am joined by Paul and Matthew from Leica Geosystems, all the way in. Oh, I was going to say London, but Matthew, I know you're in Nottingham. Paul, where are you?
I'm near Birmingham, which is about a couple of hours north of London.
So neither of you are in London. Anyway, thank you for joining, guys.
Thank
Hi,
you.
thank you for having us.
I would love it if you can just explain what is reality capture, why do we need to capture reality, and how do we do it?
Okay, no worries. So I think the first thing to say is kind of my first interaction with what we now call reality capture was laser scanning, right? So this is just using the process of laser scanners to capture the 3D space with integrated cameras to capture the imagery, and then you build up, a point cloud or ultimately maybe a mesh deliverable from the back end. But reality capture now kind of, if you look at the portfolio from a Leica Geosystems perspective, just extends across so many things. I mean, Matthew knows the graphic, and there's like 8 or 9 products in this lineup now of technologies from Leica Geosystems. So everything from handheld mobile mapping systems right the way through to airborne laser scanners and vehicle-based mobile mapping systems. So all of this technology, it's just the process of capturing very, very accurately the world around us. And if we wanted to talk about why people would do that, then we would be here probably all day because there's just so many use cases, and daily we're coming across new people who want to do something else with the data. So, let's say the traditional market is kind of the surveyors, the building surveyors, moving into kind of real digital twins, how you integrate that with other sensor types. You've got people with the flying laser scanners, maybe they want to do inspections, and then you've got people in visual effects and public safety. So they all want the same thing, which is just an accurate real life representation of real life, which they can view digitally, they can share, they can collaborate with other people. And I suppose the next evolution of that is how we layer upon all these different types of data sources on top of the reality capture data. So I guess that's what Matthew's doing a lot of on a daily basis, actually, with the new customers that we're trying to find within this, what we call autonomy space.
So yeah, Matthew, before you talk about the devices, can I just recap, Paul, for the in layman's terms, when you say reality capture, we're talking when you say digital twins, for most people in even in industry and B2B, they still not really familiar with exactly what it is. So we're talking about literally capturing information that the computer can translate and build the real world in 3D. Is that
As,
close?
as best as possible, we're trying to create a digital representation. In fact, we have the term in Hexagon, which is a smart digital reality. And I think actually that's kind of the end result of this reality capture process, because what you're trying to do, too often people will say, oh, I've captured a digital twin of that bridge. Well, actually, no, you haven't. You've captured the surface of the bridge. But actually, if
Ooh.
you were to capture the mechanics of it and the information about, the items and the what's the word, the kind of, the pipes and the HVAC and everything and the electrical systems that make up the structure, and you document that and you somehow have information about that, that's really where you create this smart digital reality, and that's kind of what we're pushing for. But yeah, in layman's terms, it's using laser scanners and cameras, or just exclusively cameras sometimes, but primarily laser scanners and cameras, to map the surfaces very accurately, to down to a couple of millimeters in terms of accuracy, and
Amazing.
obviously create these representations. Some people just use what we call the point cloud, which is just the points in space with with XYZ a point in space with color information. But then some people will further iterate on that. They'll create what we call BIMs, building information models, or maybe they'll just create meshes. But that is not the endpoint necessarily. That's just part of the process to deliver this kind of rich, immersive, smart digital reality. So hopefully that breaks it down a little bit easier. But at the end of the day, it's just about accurately mapping the space. And as a business, we have technology which goes right down from the object level on the Hexagon side all the way through to like airborne cities, That's the kind of breadth and scope of the technology stack that we have available within Leica Geosystems.
Wow. Okay. So Matthew, Paul mentioned the graphic with the devices. So I know you have the BLK to go and to fly. Can you explain a little bit about what kind of devices are used to capture reality?
Yeah, that's interesting. It's been a very interesting evolution that's happened over the past, I would say, 10 years. I got into laser scanning very, very early on by watching a program from National Geographic called Time Scanners. And it was scanning Petra and these types of things. And I was fascinated because I never knew about laser scanning and these types of things. And here's this machine capturing what is in front of you, but giving it some sort of like ethereal, ghostly image, and you can walk through walls and you can see underground, and that really, fascinated me. But what they didn't show you there was this poor guy was in the middle of the Egyptian desert capturing the pyramids of Giza, and he had to do like 500 setups on a terrestrial scanner, and then afterwards stitch it all together. But it seemed so, fluid and elegant and
What year
just
was
there.
this? How long ago are we talking?
Wow, I'm talking about probably 15 years ago, 15 or 12 or 15 years ago, I think. And and that just hooked me. I mean, from there, I just wanted to get into the industry, and I'm here now. And the other day, I was picking up one of these instruments. That's the latest daddy of that instrument that scanned the pyramids, or even Petra. And we actually took a photo, my wife and I, because she's like, "Oh, that's what got you into this in the first place." But from there, from that terrestrial setup, we've moved into this whole thing using robotics algorithms, things like SLAM, for instance, which is simultaneous localization and mapping, which is a robotics algorithm just written in the first initial instances to give a robot self-awareness of its environment. Now you've applied that to something that uses the sensors to find out where it is in space and time to actually create a map while you're doing it at the same time. So the evolution into that space where mobility has now come to the fore was a great thing. And that's been going on for about, I would say, 5 to 6 years now. But what's even going further into that is that we're removing people from hazardous environments. We're covering a lot more space. We're taking to the skies using that type of technology. So it's really, there's a lot of space to cover. Paul was talking about a lot of cities. So there's a lot of space to cover. And I think the advent of autonomy was really push that boundary for us and really let us look at the smart digital realities a little bit more while the machines are doing the work. It sounds very much Terminator-like, but that's what it is. We're actually removing the data capture requirement from the humans because we've got competent machines that are reliable, don't strike, these types of things that can actually capture that for us. So in that space, I'm really, excited to be in the autonomy space and looking at things like quadruped dogs and flying laser scanners and wall climbing robots and these types of things that actually assist us in capturing the environment, but also making sense of, as Paul said, the other layers that go with that.
Two things that Paul said that I'm still thinking about. Capturing the bridge, you haven't really captured it unless you get all the nuts and bolts and pipes inside it. Right?
Well, potentially, it depends on how much information you need. I mean, this comes down to the job requirement, right? So actually, how much detail does a specific job require? But if you're trying to create a true digital twin, then yes, you need to understand not only this, you need to understand the surface structure, you need to understand what it's made of, you need to understand how that object ticks, and if I jump into a brick, can I get information about when it was installed? What kind of meta information, metadata do we kind of have associated with that? So Matthew's done stuff actually where, like, fire safety, and you're kind of using the devices to capture the space, but at the same time, the devices now, because you compare them with like smartphones and tablets, you can take photos, do voice notes, you can do movies, and that becomes embedded within the data set. So further downstream, when you're sharing that with an end user or you're putting it on a cloud platform for someone, that information is still there. So they can see not only the shape and form, which is very accurate, but then actually see the information about, let's say, I don't know, a valve or a fire extinguisher or a smoke alarm or something within that space. So it's just adding on all these really cool layers of information on top of the spatial data. And I think that's going to be over the next few years as well. Matthew mentions this, not only automating the data collection, but automating the analysis of the data. So we push that data into, let's say, a cloud platform, and it automatically extracts and classifies and tells us, what's a fire extinguisher, what's a smoke alarm. We then add the information about when it was last serviced, and it's linked into back-end systems like SAP and all these other programs. So it just, I think we're in a really good place, but there's still much potential for growth in terms of what we do with this data. And that's where, as Matthew alludes to, where do we take machine learning and AI further down the line to automate a lot of this? And you can see kind of the embryonic discussions happening and people wanting this stuff. But yeah, I think we're getting faster. There's only so many points you can collect every single second before your computer just goes poof, or your mind goes bush. But how do we leverage automation on the processing side as well, not only the data collection but the processing side, to really speed this up and make things intelligent? So I think especially that's the division that Matthew works in, the autonomy side, and they're making a big push in that space. I think it's really exciting.
Yeah, I said two things, but you answered the second thing also, which is no, which is good, because you said just mapping it was not the end. That's not the end. So there's much more, and you kind of described what the next step was, which is to process the data.
It's a cyclical loop. Is that the right word? Cycle. It's cyclical.
Yeah, that's a word, Matthew.
I read my dictionary.
Circular.
Circular. I always think of it as a circle. It's like I'm reading this great book called Underland, where they're talking about all the Paris underground and how it basically perfectly emulates the above ground city that has been hewed from the ground and has created this underground labyrinth. And there's always that duality, life and death and shade and dark and these types of things. But when you talk about the smart digital reality, the smart digital reality is being created, although it be autonomous or whichever it may be, and with all these beautiful layers. But also, as Paul alluded to, it's the fact that you can run simulations in there. So with others, you can now see into the future. You can think about what could be by taking that environment digitally and knowing that there's no fear of loss of life or structural damage or whatever it may be, and running simulations on, is my heating correct? Would it withstand a earthquake? What is the wind tolerance? What is the wind shear factors? These types of things. How would it stand up against ocean rise, whatever it may be? And you can actually take that and then push that information and those findings back into the real world as actions. So and once you've done that, you evaluate again, and it's that cyclical loop that I think that is enabled by that smart digital reality. And I think that's really powerful.
I think what you really interesting, Matthew. We actually there's a part of Hexagon called MSC software, Tan, and they do what we call computational fluid dynamics. And if we're trying to drill that down to kind of layman's terms, it's basically airflow, it's water flow, it's looking at how things move through the 3D space. So we feed it with the data, the spatial data, and their simulation gives us a feedback of what that looks like. Like Matthew said, how does water flow through a city or something, and then we feed that back in. But the other really cool thing now that we can do is we're not just feeding it back in a really boring staid way. What we're doing is we can actually have like an augmented reality view, so we can pull up in real time our simulation in the space that we've created, and it will actually show us the simulation through our tablet or our phone. So we've got people making decisions going, oh right, there's a cold spot over there because of this air and they can go and make a real time decision based on that information that they're seeing on the augmented reality. So and Matthew knows this as well as I, this is not an easy process, right? But it will get easier. But at the minute, we're still trying to understand, what are the extents of how we use this data? Because, like I said at the beginning, it's just the start. If we start putting, piling almost infinite layers of other stuff on top, it becomes very, very, very compelling. And this statistic about the number of people moving into cities and how many people will live in cities by 2060, cities have to be smart, which is why there's this whole move around smart cities. Part of that smart city movement is making sure it's accurately mapped in the first place. So, this is where we're using all kinds of different hexagon technology, right the way from the sky down to the ground to provide that accurate map. Not to mention all the positioning technology that Hexagon has, like Veripos and all these other things as well. So it can get really deep, but fundamentally, it's all about improving people's lives. Fundamentally, it's also, like Matthew said, with simulations, trying to make this feedback loop as quick and as automated as possible, so we can iterate without any risk, and we can actually make decisions based on that.
And is it fair to say that today there's not much consumer use cases? It's still in the enterprise and industrial space.
Maybe let Matthew answer that from a customer perspective, who he's selling to. I have a view, but I'll be interested to hear what Matthew says first.
Yeah, I think there's some bits and bobs being used by people, but look, the large drive and the large visions would normally be driven by the big corporates. There are organizations that are forward thinking that take some of these technologies and build very niche use cases and very niche applications for it, not on a grand scale, but for a very specific type of application. We've spoken about these simulations that you can run on a 3D model. So capturing an area very, very quickly, a school, for instance, with a handheld laser scanner, and then running a simulation on airflow to look at spread of disease or sickness or flu or whatever in certain seasonal changes. That is something that one organization can do. It's smaller scale, but it's something that they can apply quickly, and they build a business around that. So there's adoption from smaller companies, but there's also adoption looking at the whole workflow. So looking at our collaboration with people like our Evolution, that type of thing, where you're taking everything in the kitchen sink, from positional to laser scanning to bathymetry to everything that you possibly can, and actually apply that to make a global impact and changing the planet type of impact. So yeah, it's across the scale. I think, as you mentioned a little bit earlier in the conversation, is that not a lot of people are aware of what is. So there is some form of educational component that needs to precede these types of things. But as soon as people see the potential that is out there, that is not just data capture, like, ooh, I've captured a point cloud, but actually taking that point cloud and actually gaining valuable analysis out of it, combining it with certain other elements, that is where the real value lies. And I think as soon as people start seeing that, they'll start catching on.
The other thing as well, adding on to what Matthew said, is sometimes people don't see it, and I don't want to get too deep, but this whole notion of you only recognize technology when it breaks, right? So technology shouldn't be visible to you until such time that it breaks, right? So like my car, when it breaks down, then I think, oh bloody hell, my car's broken. But otherwise, it's my car. And the same with my phone. Suddenly my phone dies. My phone's broken. And it's the same with all this technology until there's going to be consumers that are using data. Like, for example, if we look at it like at a real consumer level, like Pokemon, like the augmented reality experiences, they're already using spatial data. They're already using LiDAR. They're already using technology that we've been talking about for 20 years, but it's wrapped up in a consumer device that they don't really know how it works, but it works. And I think that there's going to, there's this movement at the minute around using phones for photogrammetry, using phones for creating these NERFs, which is this new 3D technology. And it's just the people that make it accessible and hide the tech are the ones that are going to be successful. And I think we are genuinely seeing a shift in kind of two types of customers. You've got the traditional, like Matthew says, like the corporates, the big corporates, the global companies that Matthew's selling to, who are buying devices all over. And then you've got what we call like a track one type customer who is new to the market. They've never used 3D laser scanning before, but actually they're coming in and going, I can see a use case for this. I'm going to use this 3D technology in a way that hasn't been used before. And genuinely, we're still seeing new markets all the time. But the one like the one that seems to be on a hot topic at the minute is visual effects. Now we've seen for the last 20, at least what, about nearly 23 years, I've seen laser scanning being used in visual effects and LiDAR for various things, whether it's mapping a set or camera tracking. But now we're seeing people being able to do this at the phone level and quickly create an asset for like a prop out of using their phone. And it's not the highest accuracy, but
So when you say visual effects, you mean in the film and TV industry?
Yeah, absolutely. Yeah, and that's a big market, and there's companies out there that have got tens of our scanners running around mapping, scenes for visual effects. They are, whether it's previs planning or it's camera tracking or it's actually creating virtual props and assets for use in the film. But when you talk about that's where there's that kind of crossover, because we're seeing more and more people use off-the-shelf devices to kind of create this content. So I think that's also going to be a massive part of the future, is how user-generated content gets embedded in this, let's say, I don't want to say, but professional data. So we've got this professional level of data, and then how do we bolt on this other kind of prosumer data that can sit in the same space? I think that's a really interesting situation over the next sort of 10 years that's going to just grow and grow and grow.
And Matthew, do you see how? Because last week we talked a little bit. We got really philosophical, so we're not going to get too far in that direction.
Yeah.
But I want to ask you again.
He had me stumped when he started talking about the tunnels. I was like, "We're going that deep, okay?"
But I want to ask you. Last week you said you don't see how this is a step towards becoming. Because you both mentioned, I haven't mentioned the S word yet. You both mentioned simulation many times, several times in this conversation. So, am I just jumping too far ahead, or is this a logical step towards? Because we're already creating simulations. So, doesn't it follow that naturally we're creating a complete simulation, the simulation of everything?
That is deep.
But isn't that, aren't we on that path?
Well, yes, but to the point where it's still only a pseudo simulation, because how would we ever, okay, take it really deep and say, okay, we're never going to be able to recreate something at a molecular level, right? It's all.
You say never.
Well, mate, humans are clever, clever bunch, but for me, it's still a representation. Is it ever going to be a true simulation? I don't know, but yeah, we're moving towards being able to say, this is how something functions, this is how it operates. But yeah, I don't know. I think we're a long way away from being that clever. But certainly, if you look at the steps and progress in artificial intelligence and machine learning only in the last 12 months, completely different topic, but bringing it back slightly, is this Midjourney, which is this AI art generation tool, and DALL-E and Stable Diffusion and these other ones. And if you look at the way that they are then learning, so that the like Matthew said, the feedback loop is all automated. It's constantly, the model is constantly changing because it's constantly learning.
Yes.
And if we can get to that point and make things self-learning, then yeah, I think we're on that path towards creating a real replica, a digital replica.
Would you agree, Matthew? What Paul said. Yeah, I think the reality will address the requirements and the needs of the human race as it is. Yeah. So at this specific point in time, we are trying to clank these two sticks together to make it in the nature, as Red Hot Chili Pepper says. But to get to a point where we can build a smart digital reality so we can live in a better place, okay, or make our living space better. Will it become the space where we live better in the future? I don't know. But at the end of the day, currently the requirements, I think, would be to understand our environment better, run it better, make it safer, make it more economical, and that type of things. Those are the driving forces that we have at the moment. I think way down the line, when those drivers change, when we are comfortable with a smart digital reality and things being in a digital space as a duplicate or shadow world or whatever it may be.
A metaverse almost, Matthew.
A metaverse,
Metaverse. Wow.
almost. Yes,
Imagine.
imagine. But I mean, that type of thing. So I think we're a long way off, as Paul said. But I think currently we're addressing the current needs. And I think once those needs change in the future, then we'll probably see that moving into a different direction.
Yeah,
Wow.
it's that whole notion of in the last, what is it, in the last 50 years or 60 years, all of the knowledge that we've created in that space has been equal to the whole of the human
Yep.
race or something. And something,
Absolutely.
and then something like every 3 days now we create the same amount of content online or like on server space that was for the whole of humankind, like every few days. Like there's some mad
Think
statistics.
about crazy stuff like that.
Yeah,
Yeah.
that's but I'm not joking aside. Matthew mentioned I mentioned, but the metaverse. But the metaverse is part of that step for me of making people feel comfortable with these kind of smart digital realities. Because if you can say to someone, right, okay, we'll get you stepped into a virtual space where you can make as many cock-ups as you want, but you will learn and you will understand. And this is why there's this big push around training in VR and training in AR now, because if people are encouraged to learn and make a mistake, let's say it's a surgeon, I'd rather you cut open that artery wrong 10 times and then get it right when you're doing it for real. So it goes the same for building things. This whole idea of you build it on the computer and then you build it in real life, and that goes for so many things. So that's where our technology helps, because we're helping people build the digital reality across all the different segments, whether that's heavy construction or building information modeling, whatever, but we're helping them build the digital version to make sure that the physical version not only is built correctly, but then is operated correctly and is maintained correctly. So we've just got to make people comfortable with the digital. And actually, I think Matthew probably finds this a lot with his customer base. You've got some customers who just will grasp it and do it, right? They're so in bed with that idea of working in digital. And then you've got let's say an older generation of customer who is still very traditional. And at the minute, it's how quickly can we bridge that gap from this guy or this person to this person. And that's really interesting as well, because that's a whole other paradigm shift for a lot of people. But I think we're getting there. I'd like to say I think we're doing a good job in educating people. Matthew's nodding, so he must agree.
Yeah, I agree.
Before we finish, I just want to quickly go back to something you just said, building simulation on the computer before doing it in real life. And then earlier you mentioned the ability to bring the digital twins live on site, not just on desktop, actually in the place. What's required for wider adoption there? I mean, like, are we waiting for the glasses, better goggles, or are people still using phones and tablets?
I'll be honest. I've heard some things and heard rumors of technology that people are producing, and actually one of the major hindrances is mobile computing power and battery life. Because until you can create something where you can walk around for 5 or 6 hours in a space and have a constant, permanent, persistent virtual experience or augmented experience, then how do you get to the point of, otherwise it becomes a 10-minute thing where you use it.
You're just holding the thing.
And you put it away. So if we really want to make it truly like immersive, if that makes sense, then yes, you need something that can be more permanent. But again, there's people making power plays in this space now, and I've seen some great examples of people using augmented reality headsets on construction sites, right? That's the thing. But you're still limited. You're still limited by the computing power. You're limited by the positioning. You're limited by the battery life and all these other things. And also the software side needs to catch up. It's all very well and good being able to walk in and see like all of your pipes underneath, the space of a room. But then, what do we do with that information? So yeah, I think we're seeing the embryonic stages of it, and that that again is that part of a metaverse, like an industrial metaverse or a construction metaverse, and how then is that connected to all these different data sources? So, again, like I said at the beginning of the call, Tam, we could be talking for hours about the applications. A whole day of where do people use the data. But for me, that's where the adoption will come. But at the end of the day, people are still happy with having it on a phone. People are happy with a smartphone interface and being able to see this information. But what's the next leap, and what's going to be the driver for the next leap? To the point where people in construction are wearing smart helmets. I mean, we've seen a couple of smart helmets come and go over the years. We've seen how iterations of Microsoft HoloLens have come and go over the and Magic Leap and all these companies. People are trying, they're pushing, and they will continue to push as long as there's money and investment there. But really, what is the real world use case? I mean, Matthew, I don't know what you think about that, but that's my feeling.
Yeah, no, I agree with you. I think we're almost stuck in that representation stage. So
Yeah.
data is being represented in a specific way, be it AR, VR, XR, whatever. You can see the data. We've captured a point cloud. You can see it. Look at it. Oh, it's beautiful. It's rendered lovely. But so what? It's that transmutational stage that we need to get into, and the technology that needs to spearhead that. How do you take those pipes, map it, clash detection, get the diameter prefabricated, know exactly where to buy it, installation certificates, who's certified, what's the temperature, these types of things. What do you yield from that? How does that come back to you? How does that loop back into reality?
Yeah.
Work orders, these types of things. So there's a lot of things that that is lacking at the moment. The capability is there. With a few mouse clicks, you can actually enter that and see that and make that work somehow. But at the moment, that edge compute, human edge computing deliverable stage where we can actually view the data, play with the data, execute the data, analysis, blah, blah, blah. So I think, there's something not really there yet, I think, from a technology.
Really exciting to see the potential.
It is.
And that's what you just said. Like, imagine you walk in, click on your augmented layer, and all of a sudden you're being able to see everything about that, the history of everything within that building, or you're part of building the history. And that, imagine just like, again, thinking a bit deep, but imagine like you'd had that information for the pyramids, that someone was able to you could walk in and you would see how things were constructed, how things were layered, and all the multi-dimensions of that building, and what's the provenance of that particular brick? Where did it come from? Like I'm looking at the picture behind you, Matthew, and think, I know it's not Stonehenge, but how does it all fit together? And that in the future, maybe that's what people will have. They'll have a complete digital footprint of how something was made and maintained and looked after. And Matthew Bester on this day at this time checked this doorknob. and it's that little bit of history that's kind
David
of
WD-40.
Yeah.
16 mils of application. Yeah.
Well, crazier things have happened. Yeah.
So you mentioned HoloLens and Magic Leap. Matthew, Paul said they'll keep pushing as long as there's money and investment. In your experience, is the money and investment there, and do you think it'll continue to be there?
The drivers that trigger money and investment is saving time, keeping people safe. We address that very, very nicely with regards to autonomy. I think those are very big drivers and levers for people to say, hang on, we don't need 9 people walking around with tape measures and distos to do a room. We can have one person walking around, upload that data. It's ready for analysis, ready for work. We can cut down on cost. No people in cars, less traffic, commuting to workspaces, less overheads, less risk. So that drive, the business drivers of saving time, saving money, putting people, safety at first is there. So investment will follow. Obviously, that's what people want to invest in. They want to make sure that their people are safe, that their buildings are safe, that things are done quickly, correctly. So
the efficiency angle is a really interesting one to me, because obviously there's this whole thing of AI will take over the world and people will lose their jobs and all this other stuff. But there's actually this moonshot project in Japan right now where they're trying to make as many manual jobs virtual, so you're like virtually present. So the idea is that all lorry drivers will just be via wire, and all machine workers and manufacturers will be via wire, and
Only
they'll.
in Japan.
Well, no, but it's their project, right? It's not just
Okay.
Japan, but that it's like a moonshot project from the government in Japan, and part of that is going to be, like I said, an industrial metaverse. That people have to be comfortable with the notion of working in a virtual space. I had a meetup yesterday with it's probably about maybe 8 people from the digital marketing team within Hexagon Geosystems, and we had it in a virtual space, that was created from laser scan data. So and that was the first time I'd done it, and it was really interesting because it was just the once you get past the barrier of either wearing a headset or being on a screen, as soon as you become comfortable with it, and they become the norms, like Teams wasn't the norms before, and Zoom wasn't the norms before, but now, how do I have a call? It's just becomes the everyday. So when people fit in, or when it fits into their daily lives, then I think it's going to be just a very big groundswell effect of how people get involved, and I can guarantee, or I feel it, that Apple will nail it. I just feel that Apple will somehow nail the usability and the ease of use and the ease of access that other people just won't. And I don't know how they're going to do it. I'm interested to see, but until when that moment comes, that's going to be another paradigm shift, and we're going to get more people using the technology. And what's great is then you've got a creator economy of people who are collecting data sets, reality capture data sets, and using that to create these digital spaces. Because it doesn't always have to be a random, blocky, abstract place. Maybe I want to have a village meeting in a digital version of my village hall, because I can't get there because I'm in a remote Scottish Highland or something. All these things that you start thinking about how people might use the data.
Awesome.
And also, sorry, I was going
No,
to say,
go on.
But then, making the tools so easy that anyone can very quickly capture that space and create the 3D geometry. And that's where HXDR, for example, from Hexagon comes in, because, it's not as easy as that, but you drag and drop the file into the cloud, it creates the mesh, boom, you've got a space that you can use. So when we start making it the everyday, that's when we're going to see the adoption. So we shall see. But I think consumer level is still some distance away, but it's amazing how many consumer experiences are based off of this very high level professional data. If you look at Apple Maps, look at Google Maps, all that data is coming from somewhere.
Yep.
Most likely airborne sensors, perhaps Hexagon ones. So there you go. But a consumer would never know it.
It's big in Japan.
Almost out of time. I want to end with a couple of sentences from each of you, if that's okay. You said that you think generally we're doing a good job of educating people. Can you take a moment if you need? Just end with, I would like one sentence each from each of you. If you're educating people, can you say in a sentence the most important thing, like somebody should think about or question in a sentence?
I would probably say in one single sentence, just think about the possibilities that you have with the ability to remotely capture an environment and analyze and change that environment remotely. I think that's the power of what we have now with autonomy, that people can go into nuclear reactors and understand what's happening there where people couldn't go previously, have a good view of it, things like that. I think that would be an educational component for me.
My sentence is more around just understanding the possibilities, and also understanding that it doesn't have to be difficult. So that's the point, is there's so many different technologies for so many different types of people, and we've got entry level products ourselves, there's consumer level products. As long as you are happy with the deliverable and your clients are happy with the deliverable, then everyone should be happy. But that doesn't stop the fact that there are different levels of accuracy, different levels of detail, and people need to understand that dependent on the end requirement, there is more upfront work that needs to be done. So don't do something to the least of your capabilities and then come moaning to me in 5 years because you didn't do something 5 years ago that should have laid the groundwork. Make sure that you put the effort in early, and you'll get the rewards later on.
That can apply to all areas of life.
Yeah, that was the point. You said wide and broad.
That's awesome. That's like anyone can use that advice. Yeah, do the work early so you can benefit later.
Mm-hmm.
Cool. Paul and Matthew, thank you so much. It was a pleasure to talk to you.
Thank you for having us.
Thank you for having us. Yeah, absolutely.
I'll get some beers in next time, and we can have a metaverse party. Maybe we have the next meeting in the metaverse.
I would love that. Some meta beers.
I'll send you some details, and you can virtual beers, virtual aperitifs, and off we go.
Excellent.